Robert, imagine you're standing in the shower in your hotel suite in the 54th floor and suddenly the water stops.
Okay, Christian. And imagine you're stuck in a traffic jam in a tunnel, there's fire, and the smoke extractor system fails.
These are two examples from the infrastructure sector where frequency converters are used. Maximum availability is important here, just like in industrial manufacturing and in many other areas. But availability isn't just about equipment defects. Often it's line voltage fluctuations or power failures that are the cause of these faults, especially in areas with unstable grids.
Siemens offers smart software functions for converters that ensure operations keep going on for as long as possible in critical situations.
After a grid fault, converter motors wouldn't normally restart automatically.
That's right. When the power comes back on after an interruption, you normally have to acknowledge the fault. However, if you need an automatic restart for your application, this function can be set in the SINAMICS converter.
The fault is then automatically acknowledged by the software. You can either set a fully automatic restart or the system waits for a new switch-on signal.
The automatic restart after power failure is often combined with another function. If the power cut was so short that the motor is still turning when the power comes back on, due to the rotating mass, the flying restart function is used to synchronize exactly to the current actual speed.
So a motor that's still turning is restarted on the fly by the converter at the appropriate speed.
It's a very important function because otherwise an excessively high inrush current could lead to a new fault when switching on to a motor that's still rotating.
These two functions, automatic restart and flying restart, make a very reliable restart possible after a power failure or grid fluctuation.
Oops, lights flickering. I think we also have some unstable grid here.
Thanks to our SINAMICS converters, these short interruptions don't need to cause a plant stoppage. After all, the converter buffers some energy in the DC link. This energy can be used to avoid or at least delay an outage.
For trouble-free operation, the voltage in the DC link must always be within a defined range. Both undershooting and overshooting would cause a fault and a shutdown.
To stop the voltage from dropping below a certain limit in unstable networks, SINAMICS drives feature Kinetic buffering, also known as VDC min control. This ensures that the DC link voltage stays within the permissible range for as long as possible, even if disturbances occur on the line side.
If the voltage in the DC link drops too much, the software tries to create some regenerative power by moderate, targeted braking to keep the DC link voltage within the permissible range.
This works particularly well when high kinetic energy is available in the application. If the power is off for longer and there is not enough kinetic energy available, the motor speed is reduced further until the drive stops safely.
Besides kinetic buffering, there is overvoltage limitation, called VDC max control. This prevents a shutdown caused by an excessively high DC link voltage. Excessive voltage can occur during braking operations with high regenerative power. In such cases, the braking ramp is flattened to limit the voltage in the DC link. But that's rather a special application.
Wouldn't it be handy if we could simply combine all of the functions mentioned so far and activate them in one place?
Exactly. With some converters, the functions can also be quickly activated in combination as keep running mode. This function is often used for pump and fan drives. It does everything it can to protect the drive system and keep it operating for as long as possible, even if a fault occurs. Short-term power failures are bridged with VDC control and kinetic buffering for this purpose. After a power failure, the automatic restart function becomes active, which can also synchronize with a rotating motor using the flying restart function. If there is risk of overheating or overloading the motor or converter, the pulse frequency, the output current, and the output frequency will be reduced to prevent from switching off.
All the functions included in the keep running mode can of course also be set up individually with other converters.
What would be the consequences if the permissible temperature of the motor or converter is exceeded?
That depends. A hotel guest standing under the shower would probably have the water turned off, while the smoke and gases in the tunnel would definitely have to be extracted by whatever means necessary. For such essential tasks, there is the emergency operation mode, which is in the past was also called essential service mode. The motor and converter are literally operated to destruction, ignoring any disturbances.
We have shown you various options for boosting the availability of your plant, mainly through software functions in the SINAMICS converter.